Section 6.3, example 12, finding the Maclaurin polynomials for each of the following here. So the only difference between Taylor series and Maclaurin series is Maclaurin A is equal to 0. So if A were equal to 0, here we would lose that. We would have x to the power 1. Here we would just have x to the power 2. So Maclaurin is a little bit, I'll just say a little bit easier, not a whole lot easier, but it's a lot easier than having to do the Taylor series centered at A over here. All right, so let's get started with this first one. Let's make a little bit of room. All right, so for this first one, we're looking at the function of f of x. There we go. F of x is equal to e to the x. So here we don't have to do any real math, just because f of x, that's going to be e to the x. The derivative is also e to the x, so on and so forth. So all of the derivatives are e to the x, so it makes it a little bit easier to work with. So let's see. So for p naught, we could get right into it. This is going to be our function evaluated at 0 over 0 factorial x to the power 0. So that one is just going to be f prime of 0, or f of 0. Just plug 0 in here. We end up with 1 over 0 factorial. That's still going to be 1. So we have that. Let's move this up here. For our second polynomial, or for polynomial 1, we have this top part here, f of 0 over 0 factorial, x to the power 0, plus our first derivative, f prime of 0 over 1 factorial, x to the power 1. Which this one ends up being, here we have 1 over 0 factorial, x to the power 0, plus 1 over 1 factorial, x to the power 1. This ends up being 1 plus x. And looking at the second polynomial, why don't we just do this? 1 plus x plus the following term is going to be f double prime evaluated at 0 over 2 factorial x squared. That's 1 plus x plus, let's see, 1 over 2x squared. And lastly, our third polynomial, 1 plus x plus 1 over 2x plus the third part of our polynomials, f triple prime, or their derivative, over 3 factorial x cubed, 1 plus x plus 1 over 2x, should be squared, plus 1 over 6 x cubed. And that's it there. So those are the 4 polynomials that they wanted us to find. And P1 is this, P2 is this, P3 is this. Simple as that. But for this next one, things get a little different just because we have a different kind of function. So here we're going to have to find all of the different primes. So to start off, we have our original function, f of x is equal to sine x, one too many i's, sine x. F prime of x is going to be cosine x. F double prime of x is going to be negative sine x. And the third derivative of x, negative cosine x. Next, we have to evaluate it at each of these points. So let's get each of these evaluated at 0. Because remember, for Maclaurin series, we're evaluating all of these of 0. F of 0, F prime of 0, second derivative evaluated at 0. The third derivative evaluated at 0. All right, so for each of these, I have my unit circle here. At 0, cosine is equal to 1, sine is equal to 0. So here we have sine and sine, so these two are going to be zeros. Here, cosine is equal to 1, so that's positive 1. Cosine is equal to 1, so that's going to be negative 1 here. All right, now that we have that, we could start building our polynomials. Put a little division here. All right, so we have P0, P1, P2, and P3. So each of these have P0. So P0 is going to be f of 0 over 0 factorial. So f of 0 over 0 factorial, that's going to be 0 over 0 factorial x to the power 0. Each of these have one of these as well. And for additional ones, this one's going to have another term, so we're going to put plus on each of these. And now for the second term is going to be f prime of 0. Lost it. Okay. F prime of 0 over 1 factorial times x to the power 1. So f prime of 0 is going to be 1 over 1 factorial x to the power 1. Each of these have this. X to the power 1. And these are going to have additional terms. The next term is going to be the second derivative. So f double prime evaluated at 0, 2 factorial x squared. So 0 over 2 factorial x squared. And lastly, no, we stop there, and we add one more here. So for the last one, we have the third derivative, or you could write it as triple prime, evaluated at 0 over 3 factorial x cubed. So this is going to be negative 1 over 3 factorial x cubed. And I don't like the way this looks, so we'll just add it over here. We'll come back to you. Okay, so back here. All right, so each of these, let's see what each of these end up being. So here we have 0, so that's just going to be 0. Here we have 1 over 1, so here we just have x. This is 0, this is 0, so here we have just x as well. The last one, we have x minus 1 over 6 x cubed. X minus 1 over 6 x cubed. And there we go. Those are our polynomials for sine. And now let's see what they are for cosine. Here's something very similar. Actually, did they ask us to do anything? Ooh, they wanted us to come up with the nth Maclaurin polynomial. So over here, let me scooch this down. Right there. Okay. So for this, we see if we leave it as just our polynomials, so f of 0, the next term is going to be f prime of 0 over n factorial. Let's see if we could add it. So the nth polynomial is going to be the sum as n goes from 0 to infinity. Starting off with the function, so f, the nth derivative of 0, and n factorial. Is that what we have here? Actually, no, because I didn't want a function in function form. So we just have, it looks like x to the power n. Each of these we're dividing by n factorial. So if you notice that, so dividing by n factorial, 1 over n factorial. And I'd say we're good. So for the very first one, when we plug 0 in, we have 0, 0 factorial. So that ends up being 1. For the second term, which is just going to be that, for the second term, just going to be x. So when we plug 1 in, 1 factorial, we have 1 and x. For the second term, we plug 2 in, 2 factorial. Yes, and same thing for the last one. So there's our function for there. Let's come up with the nth polynomial. So p sub n here. It looks like, so the next one, if we look at the next derivative, the fourth derivative is going to be a negative, or actually back to positive sine x, but here it's going to end up being 0. So we're alternating. We have it, we start off with we don't have it, we have it, we don't have it, we have it. So alternating, we have the sum as n goes from 0 to infinity. The first function we have is going to be x. So that is x to the power n. They alternate because we have our positive, we have our negative, so we have to throw that in there too. So -1 to the power n. And we have our factorials. So 1 over n factorial. But here we have like our 0 factorial, that one doesn't count. Here we have, it looks like 1 over 1 factorial for these two. So 1 over 1 factorial. And then we jump over to 1 over 3 factorial. So it looks like we're doing all of these odd numbers. So instead of n, it should be 2n is going to be +1 or -1. Let's do +1 factorial. Just to make sure when we plug 0 in, we end up with 1 factorial, which is exactly what we wanted. 1 over 1 factorial. And now for the first one we have is x. So x should be positive. Okay, so this should be an odd number here. So we have 2n plus 1. 2n plus 1 for the very first term. It's going to give us x, or x to the power 1. 0, we have x to the power 1. And now let's look at this one. So we start off with positives. The second term is going to be negative. So this too should be either 2n plus 1 or just n plus 1. And there we go. That is the nth polynomial of the sequence. Okay, so since we have that, let's take a look at this one. Starting also, I do believe we're going to have something similar to what we have over here. The only crappy thing is we can't combine everything. So not everything is going to be in 2n plus 1. Because here, if we had 2n plus 1, so starting off with 2n plus 1. Okay, actually, no. We could leave it like that. Let's see, so starting off with our derivatives. So f of x, f prime of x, second derivative of x, third derivative of x. So cosine x, the derivative negative sine x, the derivative negative cosine x, and positive sine x. And now evaluating it at 0. F of 0, f prime of 0, second derivative evaluated at 0, third derivative evaluated at 0. All the signs are going to be 0. Cosine is going to be 1, so we have positive 1 here, negative 1 here. And now our polynomials. P of 0 is going to be 1 over 0 factorial, x to the power 0. P1 is going to be 1 over 0 factorial, x to the power 0, plus 0 over 1 factorial, x to the power 1. P2 is equal to 1 over 0 factorial, x to the power 0, plus 0 over 1 factorial, x to the power 1, plus the next one is going to be negative 1 over 2 factorial, x squared. And the last polynomial that we're going to look at before we come up with the rule and lastly 0 over 3 factorial x cubed. All right, this time it looks like we're looking at all of the even ones instead of the odd ones. So we'll say that P sub n is equal to the sum as n goes from 0 to infinity. Here we start off with x to the power 0. So it looks like 1 over n factorial x to the power n. The next term is gone. So I'm just looking at this one here because it has the most information. So our odd ones are gone. So it looks like it's going to be x to the power 0, x to the power 2, and then the next one is going to be x to the power 4, which we are going to have a value, right? Because these are alternating from negative and positive. We also have to throw that into, so negative 1 to the power of n. So it's not just n, it should be 2n because we're looking at all the all of the even ones, all of the even exponents. And it shouldn't be n factorial because we're not looking at any of the odd factorials. We're only looking at the even ones. So 2n factorial. So 2n factorial. Let's see. So we have our negative, positive. So that one's plus, minus, and the next one would have been plus. So starting off with even. So starting off with 0, we have not even, we have positive. And we have x to the power 0 when we plug 0 in, divided by 0 factorial. And let's look at the 1, 2, third one. Actually, no, that would be the 1 to the second term should be negative. So for 1, it's negative 1, we have 2 factorial, 1, we have x squared. And it looks like we found our function, our polynomial. And there we go. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.